about the architecture of 8085. Now, as we all know, the microprocessor is actually the heart of any microprocessor unit, any microcomputer unit. And 8085 was the most popular, and it is still widely studied microprocessor architecture. It is an 8-bit microprocessor. It is basically having 80 basic instructions and 246 operational codes, and there are 10 hidden operational codes as well. Now this is the general overview or general diagram of the internal architecture of 8085. Here we can see it's having an 8-bit internal bus with certain general purpose registers, special purpose registers, address buffer, address data buffer. This is actually a multiplexer. It's a time multiplex bus where the lower order address bus and the data bus are multiplexed together to form AD7 to AD0. That is 8-bit bus. Now it is also having an instruction register. It is having instructor decoder and machine cycle encoder. It is having an arithmetic logic unit. It's an 8-bit arithmetic logic unit connected with status flag, temporary register, accumulator, and it is having a timing and control unit. We will discuss each and every unit in brief. Now, talking about the arithmetic logic unit of 8085, it is capable of performing arithmetic and logical operation on 8-bit data. The arithmetic operations that it can perform is addition, subtraction using 2's complement method, increment, and decrement. The logical operations, which are bitwise logical operations, are logical AND, logical OR, logical NOT, logical exclusive OR operation, left shift, rotate right, rotate left, and clear. Now, talking about the accumulator, it is also known as the scratchpad register of 8085. It is connected and associated with ALU of the 8085 along with temporary register and status flag. Now it is an 8-bit register, and it is the by default register. It actually holds one of the operands of an arithmetic or logical operation. After any logical or any arithmetic operation, the result by default is stored in accumulator. Now there are certain general purpose registers. Among them are BC, DE, and HL. These are all general purpose registers and are all 8-bit in size. Now this can be used individually, and it can also be used in pair. If at all you have to use it in pair, it is only BC, DE, and HL. None other combinations are possible. Now it is also having a temporary register, which is W and Z. This is only used by microprocessor for its internal use, and it is not user programmable. Now there are certain special purpose registers. Among them, one is stack pointer. It is a 16-bit register. Another is a program counter. It is again a 16-bit register. And there is an increment decrement register, which is also a 16-bit register. Now, what is program counter? Program counter basically contains the address of the present instructions that is being fetched, and once it is fetched into the system, it automatically increments to the next address, next location of the address of the next instruction. Now SP is the stack pointer register. It always points to the top of the stack and holds the memory of the location of the stack. Now stack pointer register is basically can be used by us and also it is used by microprocessor for its own purpose. It basically stores the return address whenever a called instruction is encountered. Now let's move on to the increment and decrement address latch. It is used for incrementing the program counter content for every fed cycle. Now let us move on to the flag registers. Among the flag registers, we have 5 flag registers. One is sign, another one is 0, another one is auxiliary carry, another one is parity flag and carry flag. Now, talking about the sign flag has its significance only when a signed arithmetic operation is carried out. Now, in the signed arithmetic operation, the most significant bit is reserved for sign bit. The rest of the bits are used to determine the magnitude. Now, after the execution of a signed arithmetic operation, the sign flag acquires the value of MSB. You can see it here. Suppose after any operation we have a value here and a 1 here, means the result is negative, and 1 will be directly copied into the flag register at the position of S. Here 1 signifies that the result is negative. Now supposing we have a 0 here. Now the 0 means the result is positive and it will be directly copied to the flag register. Now let's move on to the 0 flag. Now 0 flag signifies that after any arithmetic operation, if the result itself is 0, then the 0 flag will be set to 1. Now if after any arithmetic or logical operation, if we have a valid data here except a non-zero data, then the 0 status flag is reset and it is set to 0. Now let's talk about auxiliary carry flag. Now auxiliary carry is set to 1 if a carry is actually transferred from the most significant bit of the lower nibble to the least significant bit of the upper nibble. How it can be explained? Let us try and understand. If we add two numbers, so it's 4b and 69, after addition you can see the most significant bit of the lower nibble is presently transferring a carry to the lower significant bit of the higher nibble. So only during this the auxiliary carry is set to 1, else it is set to 0. Now let's move on to the carry flag. After execution of any arithmetic instruction, if the carry is produced, then the carry flag is set to 1. In this particular example, you can see that a carry has been generated and is directly reflected to the carry flag register. The similar thing happens if there is no carry, a 0 will be reflected to the carry flag register. Now let's talk about the parity flag. Now parity flag register contains a 1 if after any operation we get a result having even number of ones. In this particular example, we can see that there are 6 ones and hence this particular flag will be set to 1, else it will be set to 0. Now what is the purpose of timing and control unit? Now timing and control unit is necessary for execution of all the instructions that are possible in 8085. Now in 8085 we are having a hardwired control unit. That means all the instructions are defined inside the control unit. So whenever the microprocessor encounters an operational code, it actually decodes the operational code out of 56 possible operational codes, and it activates that particular circuit which is meant for that particular instruction and generates all the related control signals to control or to execute, or which is necessary for the execution of the instruction. It is also responsible for generation of control signals like read and write for the interfacing purpose. Instruction register and decoding. The instruction register actually holds the instruction or the operational code for a finite amount of time so that the decoder can perform its operation. Instruction register is again a 8-bit register and it is not accessible by the programmer. Now there are interrupt controllers, and 8085 has 5 external hardware interrupts, namely TRAP, INTR, RST 5.5, RST 6.5 and RST 7.5. Among this, TRAP is having the highest priority and the lowest priority is INTR. Now this can be used to temporarily interrupt the microprocessor to perform certain work. We will discuss that when we will take up the interrupts for 8085. Serial I/O control. Now there are two pins which are used for serial data communication. One of the pin is actually serial data out pin. That means it can be used to take out data serially from that particular pin, and another pin SID is used to transmit data into the microprocessor from the outside world in serial fashion. So in this particular lecture we have understood the basics of the architecture of 8085 and have discussed all the blocks in brief. Hope you have enjoyed the lecture. Thank you very much.